So, for Fermi free electron gas is also called Fermi gas, because electrons are fermion. So, for one dimension electron gas, we have seen that wave function psi n equal to square root of 2 by L sin n pi by L x, and corresponding energy En equal to h cross square by 2m n pi by L square, right, slightly below. So, En equal to h cross square by 2m n pi by L whole square. So, just for simplicity we have considered one dimensional electron gas, but in reality it's 3 dimensional. It's 3 dimensional. A metal piece, if you take, so it has 3 dimensions. So, it has x, y, z along x, y, z. If its length is L x, L y, L z, again for simplicity if you consider this, it is cube. So, it is L. So, for that that wave function one can write. So, this for 3 dimension, or one can write, or let us write x, y, z, x, y, z. So, this is some constant. So, here square root of 2 by L to the power cube and sin n pi by L x. So, one can take L x, L y, L z. So, then square root of 2 by L x into square root of 2 by L y one has to write. So, there sin n pi by L y sin n pi by L z. Okay. So, this now it is not n. So, one has to write n x, n y, n z. Now, n x, n y, n z are 3 quantum number, and this wave function is basically a standing wave. It is a standing wave. So, using this wave function and corresponding energy one can find, but it's there is a simpler way to deal this 3 dimensional problem. So, that is instead of taking the standing wave, if one can take this travelling plane wave, then it will be simpler and easy to calculate. So, this this standing planar wave, travelling wave, it's one can write for 3 dimension a e to the power I k dot r, right. So, omega t part is not necessary because it's we are interested this independent of time. So, k is basically wave vector, k is wave vector, that is 2 pi by lambda. Now, if we take this is a wave function, this is a wave function for 3 dimensional case. So, this should satisfy the Schrodinger equation. So, Hamiltonian, that is for 3 dimension, minus h cross square by 2 m del 2 by del x square plus del 2 by del y square plus del 2 by del z square, then apply on psi k r or x y z, right, r or x y z one can write, equal to E. So, I am writing this way E k. So, just to differentiate earlier, or you can write E k psi k x y z or psi r. So, this is the one condition that this wave function has to be the eigen function, where this E k will be the eigen value. So, if so, then this will be called this eigen function Schrodinger equation. So, here now again this similar, this we have to get the appropriate form of E k and appropriate form of wave function for our problem. So, in case of travelling wave, it is not standing wave, it is so travelling wave means it will in space, it will have the periodicity, right, in terms of lambda. So, in this our case in terms of length L. So, this wave function has to satisfy that condition, that periodicity in space. So, that means basically psi x periodicity, as I told this in terms of L, y z has to be equal to psi x y z, right. So, that periodicity has to satisfy it, and similarly for y z one can also check this psi x y plus L z equal to psi x y z, and for z also one has to check the condition of periodicity. So, for this, if this is the form, So, you can see that wave function a e to the power I. So, I can write k x k x x. If I write k x x plus other terms will be there y z, right. So, this x plus L other term one can write plus I k y y plus I k z z, okay, equal to for this other side a e to the power I k x x plus I. So, let me put in without putting I here, you can put I here. So, here k x k y y plus k z z, okay. So, obviously, from here you can tell that e to the power I k x l, it has to be 1, right. So, 1 means e to the power I can write I 2 pi n I 2 pi n, it is not n pi, check, it is not n pi, then it will not be 1, sometimes it will be minus 1, cos term is there, cos theta plus I sin theta. So, cos pi is minus 1, so we have to avoid that one. So, that is why we have to write 2 pi n. So, it is always in terms of 2 pi, 4 pi, 6 pi. So, it will be cos 2 pi n will be 1. Okay. So, from here what we are getting? We are getting k x l equal to k x l equal to 2 pi n, right. So, k x equal to 2 pi n by n. Okay. So, similarly, one can get k y equal to 2 pi n by L, k z equal to 2 pi n by L. So, put n x, n y, n z, right. Okay. So, k x, k y, k z, so they can vary as a this all three, they can take value 0, plus minus 1, plus minus 2 pi by L, plus minus 4 pi by L, right. So, that is the k x, k y, k z, they can vary like this. Okay. So, in case of okay, so in this is the wave function, just arbitrary wave function we have considered. So, now what about k? So, here you have k x, k y, k z. So, we could find, so from periodicity condition, so we could found that the value of k x, k y, z will be like this. Okay. So, then our Schrodinger equation here, this form is now this form is now a e to the power I k x x plus k y y plus k z z, where k x, k y, k z can take these values. Okay. So, now from this, now this wave function has to satisfy this equation, Schrodinger equation, right. So, now you apply here, if you apply this Hamiltonian on this wave function. So, what you will get? I will get, so this just you put this on here. So, what I will get? I will get minus h cos square by 2 m, then it is a will be there, and so del 2 del x square. So, it will act only on this, right. So, I will get basically k x square, I will get k x square, then from here I will get k y square, then k z square, and then this wave function e to the power I k x plus k y, k x x plus k y y plus k z z equal to e k a e to the power I k x x plus etc. right. So, from here what we are getting? We are getting E k energy expression, E k equal to so I did mistake. So, I is there. So, I k x will come out. Okay. When you will differentiate I k x, so I k, so twice I k, so I square minus 1, I square minus 1, so minus 1 minus 1 minus 1 minus and this minus plus. So, it will be h cos square by 2 m k x square plus k y square plus k z square, right. So, that will be the energy so So, now you can write in this form k x equal to 2 pi n x by L, right. So, this is one form, this is one form. You can also write in terms of 2 pi n x by L, etc., right. And wave function already, I think that is the wave function. Psi k. So, here, so for 3 dimension, right. So, psi k equal to a e to the power I k dot r, that you can write E where okay. Yes, I do not need this. So, this is the result we obtained for 3 dimensional case. So, this is the wave function for this problem. Now, if we apply operator on this wave function, okay, so you will get eigenvalue. So, on this wave function I applied this energy operator, I got this one. If I apply momentum operator, operator on this, so I should get momentum. So, this right, this P momentum operator. So, this operator form is this I h cos del equal to this. So, this will give you k, basically k, okay, I k, it will give you I k. So, I square minus 1, this minus. So, a square h cross, and this will give you k, okay, and that will be there, psi r. So, one should write in principle k, okay. So, as if this you have applied momentum operator on this wave function, right, and you are getting this. So, this is the eigenvalue of this operator. So, momentum you are getting P equal to k h cos, okay, where k is square root of this, right, k is square root of this, and in terms of L you have this k x, k y, k z value. So, if you want to get the velocity, so one can write this way also, momentum one can write this way also. If you want to get velocity, so velocity is so momentum by m. So, velocity will be k is cos by m, Okay. So, if you look at this expression, so I can tell this is a, so this is the equation of sphere in K space, right, because you know sphere equation x square plus y square equal to some r square, that is the radius of a circle, this equation of radius, equation of circle, and this in 3 dimension it will be sphere, right. So, this is in x y z coordinate in space, okay. This is the sphere. So, this is the similar form, right, this is the similar form. So, this in K space, momentum space, Fourier space, it is so reciprocal space in case of crystal, right. It is reciprocal of this length, you see. So, it is the equivalent to reciprocal space, K space, okay. In K space, so it will represent a sphere, okay. So, basically coordinate system in K space, this is the Kx, this is the Ky, this is the Kz, right. So, this will Kx square plus Ky square, it will represent a sphere, okay. Anyway, so it will represent a sphere in K space, where this is the K value, this is the K vector, and it has component Kx, Ky, Kz, right. So, this volume of this sphere will be 4/3 pi K square, right, K square, right. And if you look at this value Kx, Ky, Kz, okay. So, here this smallest value is, so if you take origin, the 0 value Kx, Ky, Kz, origin 0 value, and then next one is 2 pi by L, then 4 pi by L, right. So, the smallest one is 2 pi by L. So, as if along Kx, Ky, Kz, so taking smallest dimension 2 pi by L in all 3 direction, you will get a elementary volume. For a particular set of Kx, Ky, Kz, right. And this Kx, Ky, Kz, in that volume you will get only one set of Kx, Ky, Kz, or a particular wave vector, K, and corresponding Kx, Ky, Kz value, smallest value will be this, okay. So, that is the smallest volume is 2 pi by L whole cube, right. So, within this sphere, in that volume, how many elementary volumes are there? which this volume will represent basically one energy state, one orbitals, because kx, ky, kz now it is nothing but the quantum number. It is nothing but quantum number, but with different, just multiplied with some factors. So, it is kx, ky, kz quantum number. So, for a particular set of 3 quantum number kx, ky, kz, so its minimum volume is this. So, now in this volume, total in this volume, how many states will be there? How many orbitals will be there? So, this k square I can replace 2 pi n by L square, right, 2 n pi by L square, and okay. So, I have to tell something more about this. So, this sphere we have considered here kx, ky, kz. Now, if I consider that the electrons are or orbitals are we have n number of electrons. So, now electrons are placed in these orbitals. So, how many orbitals we need to fill? How many orbitals we need to fill or to accommodate this n number of electrons? Okay. So, if I tell that, okay, this is the sphere. So, this whatever k value, so here I will go back to k square. So, whatever the k value, at which k value, up to that k value, if we write that is kf, up to that k value, if electrons are filled. So, this the uppermost orbitals, that is where electrons are filled, then that is called Fermi level, and if its momentum is kf. Okay. Now, up to this Fermi level all electrons are there, So, how many levels are there? So, from here I can say that is the volume of the sphere, and for each orbital this is the volume. So, that will be this divided by this, that will be the total number of orbitals, and each orbital will contain 2 electrons, one is spin up and another is spin down. So, I will multiply with 2. So, then this will be equal to n, total number of electrons. So, here this kf we have chosen the outermost the orbitals which are filled, and that is energy of that orbitals is called the Fermi energy, and this Fermi wave vector. Okay. So, from here you can find out this value of kf, So, just do it. So, it will be 8 pi by 3 and here 8 pi cube. So, you will get here pi square. So, this 3. So, I will give kf square divide by 3 pi square, right, and then this will go up L cube. Okay. This will be equal to n, right. So, basically your kf, that is the value total, this is the total number of electrons n, and then from here you will get kf, I will get kf equal to 3 pi square by 3 pi square n by L cube kf square. So, this 1 by 2. Yeah. So, I think that is the value of kf, 3 pi square n by v. Okay. So, L cube one can write v volume, L cube one can write v volume, right. So, here I can write v volume, right. So, your 3 pi square n, but this is I did mistake, it seems kf cube. Okay, that is what. Okay. This volume is not kf square, kf cube. Yeah. So, that is the reason I was not able to get the correct result kf. So, it should be 3, right. 3 pi square n by v, 3 pi square n by v 1/3. Yes. So, here you can see this kf, it depends on the density, you know, n by v. So, total number of electrons in volume v. So, this is the density, number density, right. So, this kf is a proportional to the cube root of number density, cube root of number density. So, if kf is known, so what will be the EF? EF, this is the, so this is the kf, right. So, this, if I take this one as a kf, okay, for Fermi, kf. So, kf square, right. So, your energy Ek, E not k, EF, okay, for Fermi 1. So, that will be h cross square plus 2 m, and this is kf square, okay, and kf square is this. So, if you put this one again, it will be 2/3, right. So, again this energy is, again energy will depend on only on density, right, number density of orbitals or energy levels. Okay. So, I will stop here, we will continue in next class. Thank you for your kind attention.